trying to show my 3D in a cool HTML. Turned out was not that easy. It didn't work so well. So I tried browsing around for an answer. Took so long till I found this orange website where I heard singing this song. Web3D is the place to be. Here your scene will not freeze, it will show like a breeze. You'll see Web3D, you can join for free. Thanks Chronos and Ivy, and you can log in and then leave. Web3D is in Italy, with the sole and the mare, the best of mangiare virtually. Don't be mad, don't cry and be sad. You will follow our rants, dress code underpants. Now picture that at Web3D. It's so fun to be. And the social event takes you a tower that's bent. You see Web3D is in Italy. I hope you enjoy it. Good luck and then fun virtually. I was trying to show my 3D in a cool HTML. Turned out was not that easy. It didn't work so well. So I tried browsing around for an answer. Took so long till I found this orange website where I heard singing this song. Web3D is the place to be. Here your scene will not freeze, it will show like a breeze. You'll see Web3D, you can join for free. Thanks Chronos and Ivy, and you can log in and then leave. Web3D is in Italy, with the sole and the mare, the best of mangiare virtually. Don't be mad, don't cry and be sad. You will follow our rants, dress code underpants. Now picture that at Web3D. It's so fun to be. And the social event takes you a tower that's bent. You see Web3D is in Italy. I hope you enjoy it. Good luck and then fun virtually.
Hello. Yes. that's the level. We have a theme song. Good afternoon for our European friends. Good evening from those for the Eastern countries, and good morning from those from the Western countries. Welcome to the 26th edition of Web3D. It's really an honor and a pleasure to be sharing this, to be hosting this event. My name is Fabio Ganovelli. I'm the co-general chair of the event. Yes, the chair of the event. I will now say just a few introductory words and then leave the floor to Anita Vele, Marco Callieri, and the others. Okay, let me find the proper window to share. Let's see, it should be this one. Okay, let's present. I'll give it a second. Okay. So I say it's an honor and a pleasure to host this edition. I should say who us is. Who are we? So we are the Visual Computing Laboratory, is a group of the laboratory of the National Research Council of Italy, which is the largest research, non-academic research body in Italy, which has institutes scattered all over the countries. The biggest of one is in Pisa, and we belong to this place you can see in the picture. Our group is roughly made of 20 researchers, mostly permanent staff, and they're, as usual, PhD student, postdoc, and thesis and grants, etc. What we do, so why we're hosting this kind of event, we are especially active in broadly speaking, let's say computer graphics, computer vision, and loosely speaking again, in three big branches. One is computer graphics for cultural heritage, so digitization, support to state documentation, restoration. And one is more on geometry processing and the tools for fabrication, so how to print stuff well or mold them well. And the last one, if you will, is more a classic one, so real-time rendering, multi-resolution technique, virtual reality, augmented reality, etc. We are pretty active in the community. We do a lot of software and we release a lot of software. So it's research and it's also transfer technology transfer in a way. So we have several products you maybe use it in your life. One of these, maybe MeshLab, maybe 3D Op. So this is just to say more or less what we do, why we are hosting Web3D. And the conference organization is, I'm one of the general co-chair. The other one is Carol McDonald from Next Concept. We have Marco Callieri and Yvonne Young as program co-chairs, and Francesco Banter and Marco Potenziani as organizing co-chair. And you will see that we are mostly from National Research Council, of course, mostly from Europe, and mostly for public bodies. There are many other people involved. I'm only listing them here. So there is a full special track on cultural heritage. They have their own committee. So there are poster tutorials, industrial use cases, social events. You will see these things in more detail in a couple of minutes. And when we started this adventure was more than a year ago. Definitely it was almost 2 years ago. So before COVID went off. And the idea was that we would have run the conference in person in Pisa in June. Okay, this is a perfect combination for us. We have done many other times. It's really not a problem. We have the facilities, and June is perfect in Pisa, just the best month of the year. The weather is great. You can sightsee, you can go to the sea even. So it's very nice. But then the previous edition was moved to November, sorry, and so we couldn't do in June, and we definitely couldn't do anymore in person. So we had to do in November, and we had to do it virtually, which is not necessarily a bad thing, because the weather in Pisa in November is awful. It rains a lot, and it's very bad for whatever you want to do. Now, incidentally, this year is not so. The weather is great this year, but now it's too late to go back. So let's move to the next slide. So the real implementation is virtual, as you may have noticed so far. We are using Whova, so it's a platform for conference management. and combine it with Zoom for the live presentation. You can give feedback to Zoom and make question and have answer in the Whova platform. We encourage you strongly to use Whova platform, not just because we paid for it, but because it's the means we will use also to give all the announcement, broadcast messages, and whatever we need for the conference. So we'll be able to make questions. You could talk to the authors even after the presentation. We definitely can make new connection and step today with announcement. We are also broadcasting the conference to live streaming on YouTube, just for those who want to watch it. But the registration is free, so there is no real reason to stay just watching on YouTube, okay? We strongly encourage you, if you have some friends who's watching YouTube, tell them they should register. It's free. Finally, I'll talk just a minute about the social event because it's not in the scientific program. So I'm covering this now. It will be duplicating, one for more comfortable for the eastern part of the globe, the other more comfortable for the western part, and always comfortable for us. And it will be a guided tour. It will not be a video. It will not be a presentation. We have seen this solution in other conference. We didn't like it. But it will be a tour made with panoramic images. You will be able to browse on your own for the city, but there will be a professional guide. So you will be also able to follow your guide. It will be like Google Street if someone else is holding the mouse, if you want. So this is in the program. You can see also here the timing. So I recommend you don't miss it because we have done, we have implemented an ad hoc app for this, just for this conference. So I really hope you will enjoy the conference, and I will leave the ground to Anita Vele, who will say a few words on behalf of the Web3D consortium now. Anita?
Yes, can you please hear me?
Yes, sure.
Yes, okay, let me share my screen. Do you see it, Marco? Yes.
Yes,
perfect. Hello, everyone, and welcome to our 26th annual Web3D Consortium. Those of you who do not know me, my name is Anita Habele, and I'm the Executive Director of the Web3D Consortium. The Web3D Consortium, together with the ACM SIGGRAPH, puts this conference together. This conference is sponsored by ACM SIGGRAPH in cooperation with the Web3D Consortium. Together, we have been educating and collaborating with the 3D community for over 25 years. So this year, as you all know, this conference is hosted by CNR's Visual Computing Lab in Pisa, Italy. We were hoping to meet in person, but as the pandemic situation got worse early this year, we decided to make this a virtual conference. We also would like to thank Chronos and IBN for their sponsorship, for their generous sponsorship, because of which we could make this conference a free conference for all attendees. Before I start, the first thing I want to do is thank the conference committee, conference chairs, along with organizing chairs, program chairs, steering committee, the international program committee have been working diligently for many months to make this a successful event. So on behalf of the Web3D Consortium, I really want to thank you guys for all the hard work. They put together a knowledge-packed program together. And I hope after this conference, we all will leave more knowledgeable about the research and the 3D technologies that are available today. So my next slide is a very busy slide. What I'm going to do is I'm going to take you down the memory lane of the 25 years of the Web3D conference. I hope you enjoy it, and we would like to have some feedback from you on what you think about all the things that we have accomplished in the last 25 years. So our first conference was in 1995, and this is 2021, which is the 26th year. We have this conference annually. It's either in the United States, Europe, or we've gone to other continents too. So our first conference was in San Diego in 1995. And for 3 years after that, we had conferences in the US. Our first conference in Europe was in Germany in 1999. After which we started alternating the conferences. One conference would be in North America, and then we would have a conference in Europe. So this continued for many years. And then, as you can see here, right up till 2015, we were rotating between North America and Europe. So we decided to explore and go to other continents. So in 2017, we went to Australia. Then we came back to the US and Poland. And then we decided to go to Asia. That was in 2020. And we would have liked to have that as an in-person conference, but because of the pandemic, it had to be a virtual conference. And here we are in 2021 again, in a virtual environment. We were hoping for this to be an in-person conference, but we couldn't do that. Hopefully next year, we can all meet in person and be able to share our knowledge with each other. I'm also going to share with you some of the technologies that we have showcased during these 25 years and how they have evolved. So as you can see, we started out with Bromo, and then in the early 2000s, we had X3D. There were several open source implementations. This was a standalone 3D solution. The web technologies were not advanced enough to support 3D. Then came Collada, which was a very good interchange format for our tool chain support. And then in the early 2000s, when Webgl was developed, I think it really gave us a push on having real-time 3D on the web. The web browsers started supporting Webgl, and we started integrating our open source implementation with Webgl. And then we had several open source implementations, X3 DOM, Xsite, 3JS, Babylon.js. We also started seeing 3D engines coming in like Unity, Unreal. And now we are in 2021 with Gltf, HTML5, WebVR, WebXR, and we have X3D 4.0 that integrates all these technologies together and support it. So as you can see, as hardware has accelerated, we've had improved GPU processing, advanced software support, robust 3D engines, new web technologies. They all have converged to really give us a true real-time 3D experience today. And this has all happened because of open source development and research. As you know, many 3D solutions have come and gone. But what has really sustained our open solutions, standards-based solution? And that's what we have been focusing in our conferences. And I hope during this conference also, you will learn the importance of having open solutions and working with all the standards bodies to converge our technologies to have something that's really open, robust, interoperable on the web. So here again, we've been really doing this by evolving technology, by collaborating with industry and academics. We've been trying to outreach to the community We've been having hackathons and conferences just to spread the word and just to educate everyone on what is available today for 3D technology. So one of the goals the Web3D consortium really has is not only to provide specification for open 3D graphics on the web, but mostly to outreach and have education programs to encourage using open standards for 3D. And that's why we are here today. And this helps us empower 3D and VR developers and also guide policymakers and leaders, some of whom here who are on this call, on what is available today, what methodology should you use to develop your 3D solutions. So what we did was we wanted to see a footprint. So last Friday, Dawn and I decided to go and check our publications on ACM. And here's what we found. This is really impressive. So over the 25 years, we have had 600 publications, 5,000 citations, nearly 250,000 downloads. And I'm sure it's more today since Friday, since the conference has started. And we had over 1,600 downloads in the last month. So this is very impressive. It's all our hard work is paying out. Publications are available to download 30 days prior to the conference and 30 days after the conference. So if you're not an ACM member, you can still download all our publications in the next 30 days. So please feel free to do so. I'm going to talk a little bit about the consortium here, just a couple of slides, because we have another session coming up and we would like you to join us at that session where we will be talking more about the consortium. So we are an open international nonprofit member-driven industry organization, and we develop royalty-free ISO standards for 3D on the web. Our standards are X3D and HNM. So X3D models provide a scene graph to display 3D models from multiple sources. With X3D, you can add user interactivity and animation using sensors, and you can publish this on the web or any standalone device. So the active Web3D ISO standards are X3D and HNM. And again, I'm not going to go too much in detail here because we have another session where we will be talking about this. We have 3D, VR, AR, all the capabilities within X3D, interaction, collaboration, animation. For humanoid animation, we have the HNM spec. Our X3D is integrated in all browsers. So web is your platform, so you can run on any device, right from your caves, from the phone to your tablets. And if you want a standalone device, then you can also have the standalone option. X3D is used in multiple domains, and we'll be showing you some use cases in our town hall session on Thursday. So if you want to learn more about the consortium, please join us at the Web3D town hall. It's on Thursday between 6 and 7 p.m. Central European time. We hope you will join us then, because we're going to have some active discussions on how we can improve 3D technologies and how we can help you do this. So some of the questions we think you should think about during this conference is how we as a community can support you, and what are the problems you face today when making or publishing 3D. And what was the most difficult thing for you to solve this problem and why? So these are some things you can think about and come back to us during the town hall where we can discuss this further. Last but not least, we have to continue this tradition of hosting Web3D. So we are calling for hosts for Web3D 2022 and 2023. This information is available on our website under conferences. And if you have any questions, please feel free to email me. I hope you enjoy this conference and come out of it after 5 days more knowledgeable about all the Web3D technologies that are available today. Again, thank you to the committee. Thank you to Web3D Consortium, ACM, SIGGRAPH, and all our sponsors to make this a successful event. Thank you.
So thank you, Anita. And we can move on now to the next presentation, which is can you see my video? Okay.
Yes.
So I will give a short overview of the program, some news, some announcements, some things that have changed since the beginning of the conference, which was just a few years ago, and we already have changes, but stay with me. So program overview. We worked hard to create this program. The program chairs were Professor Yvonne Yang and myself, and but we the theme of the conference was a shared 3D workspace, but we also had a shared workload. So all the things that have been done in gathering the presenters, reviewing, establish the program, deciding what to keep in and what to keep out, was communal program. Effort of all the people involved. So we had a very large program committee with reviewers, chair and organizer, and a lot of other people that just gave us a hand to set up the everything. So we have, first of all, to thank all the people that helped in setting up the program as it will be in the next few days. Thanks to the sponsor for enabling us to have all the people here without a fee. And let's get to the program itself. So we have at a glance program available on the website, while a detailed agenda and a very powerful agenda is on the WUVA web app. So with that, in this system, you can explore the different day, you can add session to your own personal agenda and organize how to follow the different stuff in the conference. Everything will be streamed through Zoom, and the entire conference is basically on the same Zoom webinar. So with the same link that you entered today, you can also enter the other days, and you can stay from one session to the next without leaving and re-entering, because it's one single container for the entire conference. We have structured the conference over the full 5 days of the week. Since we were going virtual, it made sense to fully use the entire week and not have parallel session and things that are they're useful, but when you need to move physically to another country. So now it's just a matter of setting up an alarm. It may be a very early alarm for you, some of you in some of the session, but still, we have no overlapping sessions, so it's possible to follow the whole conference. In any case, everything will be recorded and made available after it has happened on the WUVA platform and on YouTube, so you can watch those sessions that you were unable to attend in person. We have tried to spread the session, trying to cover the different time zones. So you see that there are some sessions early in the morning for us, well, not so early in the morning, but in the morning for us, which is useful for people in the East Asia area, and other sessions that are later in the afternoon that are compatible with people living in the US. We try to cope a bit with the different time zone of people that wanted to attend the conference. It's not possible to make everything available to everyone at a convenient hour, because the planet is round. And it's not possible to get a very good time zone good for everyone. So let's get in detail on what we want to offer in these 5 days. First of all, we have tutorials. We have 5 tutorials, which is a good number, but again, as we were going virtual, it made sense to have a bit more tutorial than usual, because in any case, it will be possible to follow them even in a recorded fashion. So it could be helpful for the community to have a presentation of new technologies and different aspects of Web3D to help the community grow and help these new technology to grow. Tutorials are spread all over the week, and I have to say something. So if you want to attend one of the tutorials, the best way is to find the session in the WUVA agenda, and you can sign up using the Add to My Agenda button. In this way, the people that making the tutorial will see how many people are signed up, and they can organize a better presentation and try to follow the people attending live. Again, recording will be made available if you're not able to attend live due to your time zone. And we already have a scheduled change on Friday the 12th. The tutorial hands-on X3D ontology, semantic web, and 3D model query has been postponed to a later date. So you will receive via email or via a WUVA message an update on this tutorial. In the meantime, we have moved the SIGGRAPH history consideration for 3D model archiving 1 hour earlier. So it started 1 hour earlier, and it is a bit longer. So we have already updated the agenda, both the one on the agenda and the program on the website, to reflect these changes. Papers. Well, we are a technical conference, and the standard thing you come to see in a technical conference are technical papers. So we have 11 papers for the main track, divided in 3 slots, on Wednesday, on Thursday, and on Friday. Again, you can attend live. The presentation will be done with a pre-recorded video that we will make available afterwards, and then there will be a live question and answer session with the authors. And posters. We tried this year to get a different idea of posters. So since we are Web3D and the core of the conference is about putting online interactive 3D, we asked the authors to provide an interactive version of their poster. So the author of the poster will present their poster on Tuesday, but the actual interactive poster is already online and will stay on all the time. Just like in a real conference, in a physical conference, the poster is put in a room, and you can go and watch it anytime during the conference itself. So if you go in the agenda and you find the poster session, there you will find the link to the interactive online poster. So please do so. Then workshop. We have 4 workshops, which are technical presentation followed by a discussion about different aspects of the Web3D ecosystem. So stay a while and listen, and also participate in the discussion. Again, it's a good idea if you want to participate in the discussion is to go to the agenda and sign up with the Add to My Agenda button. Then in Zoom or in the WUVA panel, when you watch the session, you are able to ask questions, start chatting with all the people involved in the workshop, and we can give you the possibility of speaking and ask direct questions to the authors. So we want to have an involvement with of the audience. And then we have another thing that is new for this year. We have a special track, these online legacies and cultural heritage. So the idea was to create a space for an applicative field that is increasingly using Web3D technologies, and that field is the cultural heritage domain. There have always been cultural heritage papers in the Web3D conference. Our group also published in this field years ago in the Web3D conference, but we wanted this year to have a dedicated space. So we organized this special track with three chairs, Lois Obgenafen, Martina Revellolami, and Niccolo Dell'Unto, that managed in finding people willing to, from the cultural heritage field that wanted to send work on this conference. And we have on that special track 5 papers that will be followed by a discussion managed by the chairs and an invited expert, Paolo Di Giuseppe Antonio from University of Essex. Do not miss it, it's on Wednesday. Then another new thing that was not in the website, so we are announcing now. There will be the possibility for all the attendees to showcase their work. The idea is you have done something interesting in the Web3D world. You have published an interesting 3D environment. You have created an app. You have something to show us. You can, and you will get 3-5 minutes to share your screen and show us what you have created. And we will showcase this this creation on Friday 12th. Just at the beginning of the closing session. This is a new thing. It was not in the original call for papers, so it's an opportunity for all the people that signed up in the conference but want to share their work, and they can do so. The submission opens now and will be open until Thursday 11 at noon, and we will send instruction on how to propose your work via email and via message. Then we have other interesting session about the industrial application and different other things that we will also announce later on. Don't forget about our competition. So we have an HNIM music video, and we have a dedicated session on Tuesday showing the different submission, and then announce the winners in the closure session on Friday. The same will be for the best paper and the best paper for the cultural heritage track. The different papers will be judged during the course of the week, and we will announce the winner of best paper and best paper for the cultural heritage track in the closure. I believe this is all for this short presentation. I certainly forget to tell you something, so maybe later I will get again the podium and tell you what I forgot to say in this presentation. But yep. Okay, I believe this is all for now. And we can probably go to the next point of the day, which is our invited speaker, Fabio.
Yes, that's scheduled at 6. I think we should maybe wait for the proper time just in case, or want to start earlier.
Okay, if someone else want to, yeah, Don?
I think, okay.
You want to say a couple of words about the conference and welcome the audience? Please, podium is yours.
Yeah, thanks. And thanks for the opportunity, Fabio, queuing me that talk about the conference committee and the program year to year. Your team, you've done so well. Wow, what a program. And Marco, you and Yvonne showing us this immense program. Fabio, you're choreographing this huge team. It's huge. And I want to invite everybody listening today, but also listening in the future, to consider joining. You know, the cliche is that, boy, that's a lot of work, and it is. But I think in the middle of the night, you not only have that, oh my gosh, I got another paper to check, but you also have those insights that come from looking at other people's new work, from critiquing it, from asking, what do they mean really? Or where could this go? That's pretty huge. And I want to invite everybody to be part of that mix, because we have such a long history, but we're not carrying it around like baggage. We started in the very first year in San Diego going, what do you want to do? I don't know. What do you want to do? And each year it's been that international mix, that exchange of ideas, that posing of the hard questions. How do we scale up all the way? That's been so powerful. I sometimes think that our little conference is a team at the top of the graphics mountain, opening the window to the higher ground of the web, and finding that the graphics mountain is just a little thing compared to the whole rest of the world. So I applaud each and every contributor this time and in the past. Thank everybody. Our conference ongoing committee is happy to do whatever we can to keep encouraging this great success. Thanks.
Thank you, Don. Thanks a lot. And I believe we should take the first break here, because the invited speaker is at 6. Hi,
Fabio, we can invite anybody who's on this platform right now if they want to share anything about the conference, since we have some time.
Yes, absolutely. Yes. If someone wants. Or we can just meet here at 6.
There's a question by Carol in the chat. How do we expand the fashion industry?
Sorry, go again.
Yeah, can you guys hear me?
Yes, I can hear you now. Hi, Carol.
Hi. Yeah, I got up in time. I think as I'm looking at the fashion industry and the CAD and all of that, they like to go to FBX as a file format on an export, but yet it's crashing the computers, especially for those people with very, oh, what can I say? Kind of, I just got a Surface, right? That's all I can afford. So low end. So the question is how to really expand this to be able to be used with people that have a really light light in terms of their computer's capability, and really make that available. And so I was just thinking about it. I'm sending it up for you all to think about it as well. But how to really make this available to people who come out of it from a really creative side of things. And I think that, like that sound on Fabric, I think that would actually really help. How does it sound? That's yet another, it's not just visual on the web, right? It can now be sounds on the web. And how do we make all of that available to people?
Concerning the part of the machine capabilities, it would be a surprise to me that in fashion industry there is such a shortage of money to buy good machines. So I'm not sure if this is. But one thing is for sure that Web3D could be also the place for more involvement from the digital fashion industry. I haven't talked about this, but it was one of the things we would have liked this year to have more contribution, to have contribution for that sector. We tried to reach out. It didn't work very well. It didn't work at all. So again, for the kind of problem with that you need powerful machine to do good stuff. It doesn't come as a surprise. And I don't know about the sound though. It's think of this kind of the same. I'm not sure what you mean then by the sound. You mean?
Well, for example, in Fabric, right, they like to be able to, I mean, they see it online, but to also be able to hear it tells the creatives things about the fabric, things that the rest of us don't get, but they get, right? I mean, you can, I'm sure cotton and silk sound different, or, you know, a wool versus, you know, silk. If you're rubbing it in your hands, you might be able to pick up different material properties because it's yet another sense that's telling you something. And it'd be cool if we could throw in like the haptic sense as well, so they could actually feel it, hear it, see it. And, you know, we're getting more of the senses involved.
Yeah.
So that was just kind of a thought on how do you get all the senses involved for when you choose something or choose a material, choose a fabric.
So
You can really make the choice.
So when it comes to fabric, isn't fit also very important because it changes with the fabric?
I didn't hear the.
I said when it comes to fabric and fashion, fit is also very important, right? Because it changes with the kind of fabric you use. So there is another dynamic there. How do you make a proper fit using 3D for different textures, different fabric
capabilities, stretch, assembly methods, et cetera, et cetera. So I think that one we're working on. We have to define terms. We're at the beginning where we have to say, this is what ease is. This is what it means when you have a 3D model, and the IEEE fit group is going down that, just trying understanding body types. I mean, understanding the fact that not everybody has an hourglass shape for women, right? Or the T shape for men, right? Not everybody's got that broad shoulders and no hips for men. And so that's part of it, but also part of it, like on Material Exchange or some of the other one, the Substance out of Adobe, is just being able to get the information of the fabric. So starting there and then adding that information to the database that we can, you know, improve on to get to fit. So the answer is yes to your question. We have to do it. But for what I was explaining about the light stuff, it's not.
Carol, could I add? There's.
Yes.
Sorry. Sorry. Please finish what you were saying.
It's what? Please
finish what you were saying.
Oh, yeah, sorry, I'm getting the gap. So I guess what I'm saying is on the lightness, it would be for the students. The students in the creatives tend not to have super powerful computers for whatever reason, right? They're not into computer science, so they don't think they need it. So, but then they're going into the lighter end, the surface. So, I mean, if you could take Marvelous Designer and export that out to 3D, then, I mean, I know you're working with Unity, so it's like we just need to close some gaps, and then I think we can get there. So I'm trying to, yes?
Yeah, so let me, you said a few things. Yeah, so let me take a crack at it, Anita. And Carol, you're really posing great challenges. And I think we sometimes overestimate, the graphics community, overestimate the difficulty of these things. Because it's not possible to buy a computer today that doesn't have all the capabilities we need. It wasn't always the case. These things take time to build, but they have the chops. And we've seen that because people have put X3D on cell phones, on tablets, all the way up to caves. It still works. Next, the data in 3D is a lot smaller than the data in video, like 10 to 100 times less, because we're not splatting pixels around over and over. We're saying, oh, this is what it is, and this is what it does, and that degree of information is far less. And just the size of it means it's easier to modify. Third, we pay attention to the underlying stuff. Boy, it was a audio nerd's delight in the last session where we were saying, oh, let's start with physics. Let's start with the equations of sound. And then look at, we can use this API that the web folks have already done and take advantage of that. Oh, okay. So something even less terse than geometric definitions are equations. Those are really tight. And there's all these computational power on devices, including this one, supercomputer in your pocket, connected to the grandmother of all supercomputers, the World Wide Web, and the cloud and everything else. So what am I saying? Well, that means we get to ask questions like yours, and I think move away from, is it too expensive? Is it too big? Is it too hard? And we can just focus on the right answer. The acoustics version of that is, we think we have the right coefficient set for what are the acoustic properties of a room, of clothing, of an object. If we look at this room I'm in, it would probably take me 10,000 polygons to draw this accurately. It would take less than 100, maybe a lot less than 100 polygons to give an oral representation that was very high fidelity. Okay, 1 + 1 + 1 equals, gee, Carol, what are the sound coefficients of fabric? And do they map? And has anybody actually figured them out? I think so, but do they use them? They might be using them just for acoustic tiles or other things. Do they use them in fashion? I don't know. Very subjective. I'm not very fashion conscious, but I haven't met anybody who said, oh, I bought this clothing because it sounds good. That doesn't mean they didn't. This material felt and had a better response than the other material, so they got that one. How do we measure that? How do we do that? It's really interesting, and that's why your challenges are great, because they focus us on the real problems. How can 3D, spatial, everything help us ask and answer these questions? I don't think we have to worry about the low-level stuff. How fast is the computer? How good is the internet? Because other people have fixed that for us.
I think Anita had some reply. Yeah, sorry, go.
So, Carol, you are more engaged with the fashion industry and the fashion community. How do we encourage them to engage with us? We tried it during this conference without much success. So I think our next step would be to get them more engaged so we get more requirements from them, and then we can think about what technologies and what solutions to use.
Yeah, I'm thinking we actually might want to reach out to PI Apparel. Why I didn't think about that sooner, who knows? But they're actually having this stuff or these sessions called PI Apparel Spotlights. And it might be, and they're like in 2 hours or 3 hours, and it might be something that we could present to them as an option for 2022. So kind of let me think about that, because that's a way into the fashion industry. It's not asking them directly, but the fashion industry is comfortable with PI Apparel, and they've had whole sessions on 3D technology and all of that. But nobody's really dealt with how do we handle it to, different file formats and things like that. So I think perhaps let's try to contact them and see if we can get a session on that, or, how to set up scenes, how to teach students how to do this. Because I think it's really going to come from the students, right? I mean, who is brave enough to do it live? That would be Maria, right? It's not those of us who've been around for 25 years and don't trust technology to survive in the key moments when it has to. So I think it might be good to contact that group or Avalon, to really contact the people who are bringing technology to the industry.
And let's keep that in mind for 2022, and hopefully we can engage them.
Yeah, we'll try again. So I think we've successfully killed enough time so we can take a 5-minute break and move on to the speaker. Does that work?
Yes,
Mario?
we can have the 5 minutes break now and start again at 6 with our invited talk.
Web3D is the place to be. Here your scene will not freeze, it will show like a breeze.
You're unmuted, Fabio.
Sorry. Welcome back. Thanks, Marco. We're now going to introduce our guest, Thierry Duval, who kindly accepted our invitation to give a speech here, the keynote. So, Professor Thierry Duval, welcome. I saw you. Yeah, you're there. Hello. Thierry Duval is a full professor of computer science and head of the computer science department at IMT Atlantic, head of the Inuit team of the CNRS Labstick laboratory. His research interests are in virtual reality and human-computer interaction, especially in the topics of 3D collaborative virtual environments at the intersection of virtual reality, human-computer interaction, and computer-supported collaborative work. Thierry, it's a pleasure to have you here. We are now going to play the presentation, the keynote. Okay, Marco.
Okay.
Would you?
Hello, my name is Thierry Duval. I am professor at IMT Atlantic and researcher at Labstick. Today, I will talk about how to meet the requirements for an efficient collaboration within 3D collaborative virtual environments. First, what is a collaborative virtual environment? For me, it is an interactive 3D virtual environment where several local or distant users can join to share a collaborative experience. There are many examples of such experiences. It can be used for collaborative CAD review. It can be used for virtual meetings, for virtual training, and I will show you an example of collaborative immersive analytics, where several users at several scales can share viewpoints to examine scientific data. Here is another example of collaborative immersive analytics. Here we have two distant users. One is in Rennes in France, the other one is in London in the UK, and they are co-manipulating a clipping plane with 3 points. And through this co-manipulation, they are able to search interesting features in the scientific data. This is the most difficult kind of collaboration to achieve, while two users must co-manipulate at the same time the same object. So what is the use for collaborative virtual environments? It can be used for collaborative 3D modeling or prototyping, for virtual project reviews in many industrial areas such as automotive, clean energy, petroleum industries, architecture. In this case, it's interesting to enable collaboration between different experts with different knowledge, so that their combination of knowledge can lead to something better than a usual inspection or review of a project. We can also make distant demonstrations of complex manipulations on virtual mockup, or we can use them for virtual learning. For example, a tutor with one or several students, or more interesting, for several students that have to learn a collaborative task, a task that cannot be learned alone. We can find there are not so many social aspects in this traditional use of CVE. It's mainly technical problems that we have to tackle. Anyway, we can consider it's important to perceive some states of the other users, emotional and physiological states, to obtain a better collaboration between users. Collaborative virtual environments can also be used for collaborative gaming or collaborative meetings. For these meetings, they can be professional meetings at large scale or at medium or small scale, or personal meetings. Maybe it could be a solution for new social networking. as we can see, Facebook now, Meta, is very interesting with the metaverse. So for Meta, maybe metaverse is the future of internet. It will be a kind of collaborative virtual environments linked together. Microsoft is also very interesting in virtual meetings with avatars. Microsoft added some 3D features in its Team product. So it could also be used for new virtual living, but not sure. There are many social aspects in this new use of the CVs, and we still have the need to be aware of the emotional states of the others, especially their feelings, to be sure that they understand what we do with them, and to understand what they are doing. And the idea would be to be able, thanks to all these things, to be able to predict their behaviors. So what is the problem with the design of collaborative virtual environments? The problem is that you have to address all the same issues than for virtual reality, about 3D interaction and immersion, about various 3D input and output devices, about graphics API, but you have also to address new issues, collaborative issues. You have to share data between several machines. So you have to ensure that there is some consistency between the shared data, and you have to study how to distribute this data and how to synchronize efficiently its evolution. You have also to share interaction, because you cannot rely only on single user interactions. So you have to find new metaphors for collaborative interactions, and you have to address the awareness for user of the immersion of the other users, of their interaction, and of his collaboration with the other users. You have also to explain the roles of each user, and you have to study social aspects of collaboration. And to meet all these requirements, you have to merge knowledge about networks, computer-supported collaborative work, virtual reality, 3D user interaction, HCI, and software engineering, which globally is quite complex.
Indeed, if you want to share a co-manipulation of a virtual object by two different users, you need different input device drivers, you need interaction tools, you need one interactive shared object, and an interaction protocol that will allow two users to interact with the same object. You will need dedicated visualizer, especially if the users do not use the same system. Here we have a user in a cave with a tracking system and another one in front of a desktop. And it could be good to model the workspace of each user for better awareness of what they can reach in their physical workspace. And of course, we need avatars for better comprehension of who is collaborating with us. And then, once we have modeled all this system, we have to deploy it over a network.
So all these things that we have modeled belongs to several layers. So we have defined the needs of workspace, the avatar, the interaction tools, the shared object. It is the abstract level with the protocol to interact between the shared object and the tools. Then we have to consider how to deploy all these things at a network level. Typically, all the things directly linked to one user would be best located on the machine of this user. That's why we could put all the workspace of each user, his interaction tools, his avatar, on his machine. And then the shared object should be placed somewhere else, for example, on a central server, to make sure that no user has a better access to this shared object. And then to have a complete representation of the system on each machine, we have to make some proxies of each object of the virtual environment on each system. So on each system, you should have some reference and some proxies, but everywhere you should have the global picture to be able to have a good visualization or a good computation of the behavior of the objects. And then at the presentation level, each user will see the whole environment through his own point of view. Let's look at how collaborative virtual environments have evolved over the last decades, from the very beginning at the end of the 80s to a wide democratization of this kind of environments today. To my knowledge, one of the first groups that worked on the topic of CVEs is the NPSnet research group from the Naval Postgraduate School from Michael Zida. They were mostly interested in interactive networked and moving platform simulators. And one of the first paper I saw about NPSnet was one from 1992. It is really in the 1990s that we find the first frameworks for creating collaborative virtual environments. They come either from UK or from the US. From UK, we can find Massive, Dive, Aviary, and from the UK, NPSnet 4. So all these systems are appearing at the beginning and the middle of the 1990s. The main limitation of the CVEs at this time is the power. You need big SGI workstations. You need dedicated networks with bandwidth, but the main limitations to deploy these things is that you need power, it's expensive, and you need bandwidth, and good bandwidth, megabyte bandwidth is not yet fully available between many distant sites. The 2000s were the time when we began to optimize system. At this time, making a CVE is still touchy, but much easier than before. You still need many technical skills, but you have many more tools than before. You have the apparition of the first collaboration engines, such as SmartFox Server, Rackneck, or Photon, maybe a little bit later. They are not free to use at the beginning, but they became free, or really nearly free a little bit later. Globally, the prices decrease, the power and the bandwidth increase. So now you don't need dedicated SGI machines any longer, but you have the possibility to use strong PCs with graphic cards instead. They are less expensive. You begin to find megabit bandwidth everywhere, and for professional with dedicated networks, we can find gigabit connections. And so we begin to use the system, the collaborative system, and we're trying to use them well. And some widespread systems begin to appear, such as Second Life. In the 2010s, it is the first democratization of CVEs. Now many tools are available and much easier to use than before. We have some game engines such as Unity or Unreal Engine. They can provide integrated network features, or they allow to use external network engines. And now you just have to use them with good practices. It's not so easy, but much easier than before. About the price and the hardware, VR is possible with laptops. VR is available also on low-cost HMDs since 2014. You have a new model of Oculus, for example, nearly every year, from the Rift DK1 to the Quest 2. Many other brands, such as HTC, have provided many other kind of low-cost HMDs with the Vive, Vive Pro, Vive Pro I, Vive Cosmos, and hundreds of megabits and even gigabits bandwidth are now available at home. And now here we are. It is really easy, much easier than before, to develop immersive collaborative virtual environments. VR is available on low-cost PCs with integrated graphics and even on smartphones or standalone VR helmets. Networks provide large bandwidths and low latency. We have gigabyte connections nearly everywhere, and you can use collaborative virtual environments even with mobile networking. So no, we must also concentrate on making collaborative virtual environments useful and engaging by providing content, by thinking about social behavior that we will find in these environments. And we are still needing good programming practices and classical modelization of collaboration and good collaboration metaphors. But now it is the moment to have a quick glance under the hood to look at the network level, how we can manage consistency between the different machines involved in a collaborative virtual environment. About the consistency, let's recall the context. We want to work collaboratively, so we are to share some virtual objects, not only the data related to the objects, but also their behavior. We have remote users on different nodes connected through a network. So the requirements are to ensure an efficient synchronous collaboration. We want that on each node, the collaborative virtual environment is consistent with all the views on the other nodes. So what we want to make or to obtain is what we call some WYSIWYS. What you see is what I see. It's something inspired from the WYSIWYG paradigm from HCI. What you see is what you get. So here we want that the object that we share evaluate exactly at the same time everywhere. To do that, we need network with very low latency and with very low or no jitter. Jitter is the variation of latency during the interactions. Otherwise, the responsiveness will be very bad. So the main issues that we face are which computers should store the data of the shared objects, which computers should execute their behaviors, and how can we adapt the distribution to some particular requirements of the users.
The centralized architecture is the most common one when you put a referent on the server and some proxy to the client. So when you interact with the proxy, you ask to the server and then you get the request. The global consistency is unsure, but we have possible bottlenecks and bad responsiveness for interaction. The duplicated architecture is most efficient for immediate interaction, but we can have possible inconsistencies due to data replication. Synchronization can be difficult to achieve, and problems can occur when different users want to access the same object at the same time. The third kind of architecture is the hybrid one, which is a distribution of the centralized system. Each system can be a client or a server and can own referent of proxies. So when you interact with a referent, it's efficient. When you interact with a proxy, it's not. So it can be as efficient as duplication, as consistent as centralization, but as inefficient as centralization and as consistent as duplication, unless we could make the object, the referent object, migrate from one client server to another one.
So we've seen that each data distribution mode meets particular requirements. There are some optimization for specific trade-off between consistency and responsiveness. The problem is that generally, the model is imposed for all the shared objects of a CVE. If we can take advantage of each existing solution by combining the three of them, we would be in a situation where each virtual object could choose its distribution model according to its role and to the way we can interact with it. Each object could have its own requirements about interactivity and about consistency. We could dynamically adapt data distribution of each object according to the application requirements, the network capabilities, or the tasks performed by the users, or according to the functions that the objects fulfill. And each virtual object could change dynamically distribution model, and by this, we could be able to make objects migrate from one machine to another one. Combining these three models of architecture leads us to have a global reference proxy paradigm. With this paradigm on a node, each shared object can be represented by a referent in charge of storing data, defining behavior, and processing modification requests, or by a proxy in charge of receiving updates from referents, updating local object representation in the virtual environment, storing a copy of the data for future efficient migration, and transmitting requests to its reference. Here, the referent is not always the only referent for a shared object in order to be able to implement duplicated architecture. This is this kind of global reference proxy paradigm that we have implemented, and that leads to the architectural model of the Colavis framework in 2010. What is the situation today with this reference proxy paradigm when using widespread tools such as the Unity game engine or the Photon network engine? Photon proposes a class, the mono behavior pun, to use with Unity. It makes it possible to declare remote methods, to have distant invocation of these methods or local invocation as we want. It's possible to make a local instance referent of a shared object, and by asking if we are the owner of the photon view of this object or no, we can execute methods either on all instances or only on the referent instance. So all these features makes it possible to implement all kinds of architectures, centralized, duplicated, hybrid, and even to change to associate to each shared object a typical architecture, typical model, and to change it dynamically during the execution of the collaborative virtual environment. So it's very good because all these essential features exist. The only small problem is that they are strongly coupled with Photon, and that most probably, if you want to change your network engine, you will have to change many parts of your code. This strong coupling with, for example, Unity and Photon leads us to have a look at how should we couple the things in CVE. So what about the software engineering practices to avoid to couple too strongly your behavior and the network and the graphics API? Indeed, that's when CVEs meet software engineering, because we have many issues with software with virtual reality, because new graphics API appear every year. How to use them without recoding everything from scratch if you want to reuse your code. How can we factorize interesting behaviors that we have coded in the past? And when you consider collaboration, we have additional issues because we have several possible distribution modes. They should be isolated from your 3D code and from the abstract code of the behavior of your components. But where should it be placed? Which code must be shared? Which code must be replicated? We have several possible communication layers, but it should not affect the behavior of the shared object of CVE. So software engineering is there to make the programmers concentrate on the behavior of the content of the virtual environments without being too much bothered by the graphics and the network. I'll try to be quick on that part, which is quite important. It is the software architectural model part that can help the developers to concentrate on the behavior of their system rather than on the graphics. So there are many models that exist to separate presentation and graphics from abstraction, the behavior of your systems, such as the PAC model, the MVC model, or the Arch model. These models have been extended to cover the collaborative features of the CVEs, and they have added some layers to manage the collaboration between several machines. What remains important is the separation between the behavior of the system, the network features, the graphics APIs that you use. And these models are there to help you to architecture your system in the best way, to avoid to have to record too many things when you change network layers or graphics APIs. Let's finish by looking at the abstract level about collaboration metaphors needed to have efficient collaborations in a CVE. Once the system issues have been tackled, we can concentrate on the issues about collaborative interaction. These issues are how to manage the roles of the users, how to make a user aware of the other users, how to enable several users to co-manipulate objects, because most collaborative systems only support simultaneous manipulation of different objects by different users, and generally only one user at a time can manipulate a virtual object. So we have to adapt to modify single user 3D interaction metaphors in order to allow several users to collaborate on the same object. And we have to provide these collaborative metaphors the most natural possible, because most of them use artificial combining of the inputs provided by the users. And so it is still a wide field of research to obtain good collaborative metaphors for collaboration, co-manipulation. To provide interesting collaborative virtual environments, you need also to provide a social decomposition of the tasks and a precise modeling of the role of each user, determining who is going to do what are the rights of each user. Some examples are being able to impose to some users to follow a guide, or being able to help students or to correct them when you are a teacher, and maybe not being able to access to some private parts of another user workspace if you want that people accept to use this kind of virtual environments. One big issue of CVEs is to provide awareness, and first of all, to provide awareness of the other users. So the question is how to make a user aware of the presence of the other users, of their actions, and even of their intentions. Some solutions can be to provide an avatar for each user, to highlight active interactive objects, and to highlight them differently according to the nature of the interaction, the level of sharing of the interaction, and the user who is in charge of the interaction. To provide awareness, a lot of work has been done on the concepts of aura, focus, and nimbus. Typically, to be aware of somebody, your aura must intersect his or her aura, and his or her nimbus must be in your focus. All that work has been made in the middle of the 1990s. There are many modalities for focus and nimbus, at least visual and around, and it could be generalized for areas of interest. So here you have some illustrations of the concept of aura, focus, nimbus. But for example, we could have other situation when it can be interesting to know if two users can see the same thing. So intersecting their focus can give some information, some cues about the possibilities on their collaboration. It is commonly accepted that avatars are very useful for collaboration, but when you talk about avatar, you may think about realistic avatars. And indeed, it's not really the case, because realism is not always mandatory, and some recent work about embodiment in virtual reality show that users can feel very uncomfortable with artificial avatars that look real but not real enough. And so sometimes it's better to have an avatar that is not realistic at all, but that show the activity of the other users. It can be enough for efficient collaboration. On the same subject, another study showed that 3D reconstruction, even it's far from being realistic, is also better than an artificial avatar to represent the user in a virtual environment. Another important point is the behavior of the avatars. It is important that the behavior is as realistic as possible for non-verbal communication. Otherwise, it can lead to misunderstandings between users. So it's better to have only a partial avatar, for example, only the head and the hands, rather than all avatar if the animation of the avatar is not good. Now let's talk about collaborative interaction. It was inspired by multi-hands metaphors, which was the first step toward co-manipulations through two-hand techniques such as grab and carry, grab and twirl, trackball techniques that could be adapted to multi-user interaction. And there have been in the past many multi-user metaphors for collaborative manipulation of objects. Most of the time, they are still not precise enough or not natural enough. There have been many things that I will present some of them and some of my own results in the next slides. But either you can adapt the tools, such as the bent raise, or you can adapt the way you manipulate the object with 2 or more control points, or you can split the task between the users, giving some user some degrees of freedom of manipulation while you are giving other degrees of freedom to other users. And you can also combine the movement of several users by adding their motions or averaging the motions or last intersecting the motions. This slide is there to recall that most of the time interaction tools are inspired by metaphors of the real world, such as the virtual hand, the 3D cursor, or 3D raise, and that collaboration needs additional metaphors that are most of the time modification of these single user metaphors to allow several users to use them at the same time. So it will give some solutions such as the warped or bent raise, and generalizing the 3D cursor or 3D hands to many cursors and hands to manipulate objects. Another family of collaborative metaphors is the multi-point family, where you can use several cursors to catch an object and to manipulate it. And my first work about that was the skewer in 2006. It was a 5-DOF manipulation technique, 3 for translation and only 2 for rotation. It was not so far from 2-hand techniques, and we made preliminary evaluations with 2 users who concluded that it was easy to use and understand. We extended this 2-point manipulation to a 3-point technique. It was the 3-hand manipulation technique. It was offering a 6-DOF manipulation, and we experimented it for local collaborations. And we can see in this video how 2 users will use 3 cursors to grab an object and then to manipulate it. The difficulty here is to maintain the physical configuration similar to the virtual one to obtain the best possible manipulation. We also experimented it for distant manipulations. It was the video I showed at the beginning of my talk for co-manipulation with 3 points between Rennes and London. Another way to enhance collaboration and co-manipulation with several users is to use tangible interfaces. There are physical devices dedicated to specific interaction, for example, for selection and modification of position and orientation of 3D object. They often provide better sensations during interaction because the user is physically involved. They can be passive. We don't need necessarily dynamic feedback, but they can be active. Yeah. It can so provide force feedback, sound feedback, or vibration. And it's more difficult to use them for distant collaboration unless you could have a robot that would be the proxy of the distant user to co-manipulate with you your physical device. So most of the time, they are used only for local collaboration. One example of such tangible device is the two-user device from the team of Bernd Frohlich at Weimar University, who was allowing two users to manipulate a windshield to put it on a car. Rather than having a tangible interface dedicated only to one task, it can be more interesting to have a reconfigurable one. That's why we proposed a reconfigurable tangible device that has the same capacities of passive haptic feedback between two users that can be 2D or 3D with the RTD with 4 parts. And as you can see on the video, this system enables the user to have a much better synchronization where they are manipulating an object. It's much better than the same technique without the device. And so here you have it was the RTD 3 points, and here you have the 4 points, and it can be, the shape can be changed dynamically during the interaction as the guy is doing in the video. Asymmetry can be very good for collaboration. It can be an asymmetry of roles, of tools, of viewpoints, or scale. So the idea is to have a WYSIWYS, so what you see is what I see, but not necessarily from the same point of view or for doing the same thing. Here you have the view of a user who can see the virtual environment as a map, and he can introduce 3D visual cues to guide another user who is immersed in a cave. So the guide uses a desktop user interface to introduce the cues in the virtual environment, and the visitor is immersed in a cave, and he can use the help of the users. Here is another example where two users can realize that symmetrical collaboration is not the most efficient one, so they propose an asymmetric approach. And once again, there is one giant user and one small user. We can split the task between the two of them. The goal is to travel in a kind of labyrinth, and the giant will give the position, and the ant will give the rotation on the scale of the element that we have to move in this 3D labyrinth, as we can see here. So this is the ant, and he will be in charge of the 3 degrees of rotation, and of the scale. Collaborative is still a hot research topic. We have some very interesting work about multi-rate jumping coming from the research group of Bernd Fröhlich. And they began with navigation of two users, one navigator and one passenger. So when the navigator chooses a teleportation point, the system explains to the passenger where he will land in order to have still the same offset relative to the navigator when he will land at the teleportation end. Then they extended this to another system where the passenger can choose its relative position according to the target pointed by the navigator. And last, they have extended this concept for small group navigation. For example, they propose a predefined configuration that are best suited according to what you want to visit in a virtual museum. To enhance the collaboration, it can be important to give additional cues to users, so to augment the virtual environment, to give them a better feeling of collaboration. Here are some examples of such transformations. In this collaborative visit of a museum, the avatars are very simple. These are those parallelepipeds. It's enough to show the presence of the other users. So Roth proposed to add floating bubbles between users when they have eye contacts to give the information to the user that they are communicating, and also giving information to the other users that these two are communicating together. To show that an object is a center of attention of several users, he proposed to add particles highlight on the object. That's what we can see here. And last, to explain to the users that there are some groups that are formed in the virtual environment, he proposed to give some colors to the groups of avatars. And so on the right, you have the look of the virtual environment without all these augmentations. And on the left, you can see that it's much better. We have much more information about the collaboration that is occurring in this virtual environment. To summarize about social aspects for collaborative virtual environments, we can say that for collaborative gaming, training, e-learning, or culture, such as visiting museums, it's good to have a global understanding of the collaboration. So we have to provide feedback about the interest of the others, as we've seen in the examples. For example, also when you teach, it's interesting to give information to the teacher about how the students perceive the courses. And maybe some results about virtual agents could be used if it was possible to associate sensors to the other users, or to catch their mood or their moves, and then maybe to express it according to their physical postures if we animate avatars. About the capacity or emotional state of the others, when training or gaming, it's important to know how the others perform, if we want to help them if they need, or if we want to know if they can help us if we need help. So ideally, we should be able to obtain data from physiological sensors such as heart rate, skin conductivity, pupil diameter, and then to visualize them either with dashboards or some other 3D metaphors or augmentations of the virtual avatars or the virtual environment. And then you would be able to know when you must help the other, or when they can help them while taking more workload for you.
To finish, let's summarize the requirements for CVEs. We need WYSIWYS, what you see is what I see. To do that, we need real-time consistency of all the visualization of the users. We need software architecture dedicated to network distribution. and high-speed network with low latency. We need also distant co-manipulation of shared objects. So we need strong synchronization between users. Once again, network with very low latency. Last, we need to obtain awareness of the others and of their activities. To provide that, we need avatars with normal and predictable behaviors, interaction metaphor dedicated to collaboration, explanation of others' action and intentions, understanding of the others' limitation with their workspace included in the model of the virtual environment, and augmentation of the virtual environment to reinforce the feeling of collaboration. Last, we can wonder what could be the future of CVEs. Could it be metaverses like in the Snow Crash novel, persistent virtual universes connected all together, or grid virtual universes with hundreds of thousands of users with many immersive virtual experiences to live, or that could be similar to massively multiplayer online games? We don't know, because if it works for games, it's not proven that it could work for other use cases, especially for social networking or professional meetings. It has proven not to be a success because people don't like so much talking to avatars. Anyway, the concept is not new. It has not been a success like in Le Deuxième Monde or Second Life, but today technology is better than ever. We can really be immersed in such virtual environments. And as great companies such as Meta or Microsoft are joining the game, everything is possible now. And for sure, CVE is a major hot topic of actual virtual reality conferences.
Hello, my name is Thierry Duval. I am professor at INT Atlantic and
Okay. Hello. Okay.
Yep.
It was starting from the beginning. So thank you very much, Thierry. Oh, sorry, it's Thierry or Thierry?
Thierry, but you
Okay,
can pronounce it as you can.
Right. Thank you for this very nice talk. Let's see if someone from the audience wants to make some question. I will have a couple, but if there is someone before, I will be glad to let them. Does it look like? Well, I'm curious about one thing. Is the building of avatars, because there are many examples now that of application, even web application, that allow you to build your virtual environment and then somehow to provide an image of yourself. And most often they are completely not realistic, which is okay, or they are kind of creepy, as you mentioned, and you didn't say creepy, but is a natural. It doesn't seem right to see like your picture floating around, because there are so many. It's so difficult to recreate a virtual avatar. And I believe maybe one of the problems is that you don't have the hardware to do a proper job to make a replica, let's say, Hollywood style of yourself. So it will never look right in the near future. So my question is, do you think we will just get used to it and be content with some of this system that, you know, allow you to map your silhouette, your picture, and do some that looks kind of okay until you are close enough, then it's scary? Or you know, what's your angle on this?
Yes, I don't work a lot on these things, but I think I would prefer something that is not very realistic, but where I can recognize the features of the guy I'm talking to, rather than having a very nice avatar, but knowing that this avatar is not the real person. Personally, I don't like talking to an avatar. No, I prefer talking to a video, so somebody that I can recognize. So unless you can really customize the avatar with characteristics that make that you recognize the guy you are talking with, I think it cannot work. But okay, so maybe that some transformations
having some avatars unreal, but with features that look like the guy you know, may be enough to have a good.
So that is characterized like the person you know, but it's not really. It's not expected to be realistic, but just preserve the main feature would work better. That's all. Okay.
But it's only my opinion. I don't work on that topic.
Okay. And it was very nice your part on the guiding the user, because it's without knowing the topic well, we just ventured in doing a virtual guide for this social event, which is exactly an asymmetric guidance of the user. So there is a guide, and you are watching what the guide watch unless you want to change a little bit and wander on your own, and then you can be brought back. And so we are just guessing instead of reading literature, basically.
Yeah, that's another point. I see in your presentation a lot of things that are clearly in literature about visual cue and this idea of visually represent the interaction and visually characterize the interaction. I think one of the last slides, so to show what was interacted with and to establish this contact between avatars. And then if you try to use one of those products and things that are now offered, you don't see anything of this kind. I mean, it seems that a lot of the actual industry just try to reinvent everything from scratch every time. So if you try to use these virtual room and virtual interaction from the Oculus and HTC Vive, you kind of see things like the old school computer graphics, like it was imagined years ago. So it seems that somehow the actual production does not completely follow what has been really experimented in research. You get the same idea. I mean, it's my impression.
Yeah, I see that William Glasgow said that it's perhaps an intellectual property issue, but I don't think, because all this research is published and public, so they could be inspired by this, but most of the time they don't, and they never cite. Whatever they do, they never cite the researchers that had the ideas before them. Most of the time.
We have a question from the audience. I see it now from Carlos Andujar. For collaborative virtual environments where users share the same physical space, projection-based systems such as Cave allow users to collaborate with nearly perfect interaction awareness. How far are collaborative virtual environment running on VR headset from this ideal interaction awareness?
So, I don't know what he means by collaborate with nearly perfect interaction awareness. I don't know if he means when users share the same physical space.
Maybe Carlos, we can enable you to talk.
Yes, and I was referring to, for example, in a cave, a few users can, so there is no barrier in communicating in their voice, pointing awareness. So where the other users are looking at, are pointing at, what are they saying? But in the case of VR headsets, that headset is also a barrier for communication. So my question was in this line.
I don't know, because there are not many caves that allow several users to share the physical environment with his own viewpoint, because you need to have multi-stereo displays. So I know that Bernd Fröhlich in Weimar do some things like that. He can have up to 6 different users with their own viewpoints. But if you put 2 guys in a cave with only one tracking system for the head of one of the users, the collaboration will be really bad because only one of them will have the right viewpoint. So in most cases, you can only have one user. It's a pity with such big systems, but it's the way it works. So it's quite, it's not very often that only one cave can be used by 2 or more users at the same time with really good interaction. The interaction is only good and the viewpoint only good for one user, unless you are able to project as many couple of images as there are users in the cave. And so you need very bright projectors and high frequency projectors.
Yeah, you're right, but I mean, if the user's viewpoint is not so, if they are not far away within the cave, they get not exactly, so only the track user gets the correct viewpoint, but still all of them are aware of the gestures because they can see each other, they can see their own body and the collaborators, the body of the other collaborators. So at least there is not a barrier on the communication on where the collaborators are pointing at, where they are looking at, and so on. I was referring to that part. Maybe a cave was not a good example for.
Yeah. Indeed, some of the videos I showed was not in a cave, but in a reality center from HGI from the 90s, and we had no stereo on some videos, and without any stereo, it was good to collaborate. I don't know, the difference is that in a cave you can see your own body. In a VR headset you cannot, or not yet very well. I think that in the near future the VR headsets will be usable as augmented reality video through headsets. So you will see your body, but you'll see your only body and not the body of the others. So that's sure that with distant collaboration, you need avatars instead of real humans. You can share audio; it's quite easy now, but you don't have any physical contact, or you need a robot to represent you, to have a proxy of your colleague. It's possible. I've seen some very interesting projects where you have a robot that mimic the gestures of the distant user, and so you can really interact with the robot as you could with the real guy. But it's technically quite complicated and not widespread. Tomorrow you won't have that at home. You will only have a cheap VR headset.
Let's see if there are more.
Are there any other questions from the audience? It was really nice, interesting thought, because it covered a lot of technical stuff that probably is not completely well known to people with different backgrounds. So it was really eye-opening in many parts. Also to know that experiments and literature is available on a lot of different technical sub-problems that when you start working on these things, you just know it.
Yes. It's one of those things, there is a lot of wheel reinventing, I believe. That I get the idea, oh, I'll do this, because that's what we did. And instead of, So let's say if there are any other questions from the audience. If no,
in case you can post your questions on the
question and answer
channel or as a message. We can answer later and see later the question from the audience.
I'll be happy.
I hope that Thierry will be around to answer this week. Okay.
Again, thank you very much for
you very much again.
Thank you.
And so we can move on to the next part of the session, which is the welcome and the sponsor and the some communication about the conference in general. Let me get the presentation about the logistics. Okay, just give me a second and I'll share it with you all.
Hi everyone and welcome to WEB3D 2021. I'm Marco Potenziani. I'm from the Italian National Research Council and I'm a member of the organizing committee of this conference. Hope you have enjoyed the FIS events and the opening so far. I'm very sorry not to be here with you today, but we will certainly meet tomorrow or in the following days of the conference. In this video, I want to explain you how the conference is structured, just to give you the keys for enjoying WEB3D 2021 in the best way. As you know, this year, the calendar is very rich of events. For this reason, we work a lot to distribute them on the various time zones in order to ensure a smooth experience for all the attendees all over the world. Basically, from tomorrow, every day, we will have 2 blocks of events. The first one will be convened to follow for participants in Europe and Asia. That means the session will be streamed when in this continent it will be respectively morning and afternoon. Conversely, the second block will be easy to follow for people in America and Europe, with sessions streamed in the American morning and the European afternoon. As easy to understand, it was impossible to find a calendar that would suit all the different time zones. So, North American people will find it difficult to follow the first block of events streamed during the night. As well, it will be hard to follow the second block of session if you are in South Korea, of course, unless you are a shift worker. For all those events out of your reference time zone, do not worry, because we have already planned to upload videos and recording of each session on the WEB3D official website, just after each event will end. In this way, each of you will have the possibility to follow the entire conference and not even miss a second of the events we have prepared for you. We mentioned before the official website of the conference, that is web3d.cgraph.org. Well, this is your first resource to follow the event at best. On the website, beside the all historic information on the WEB3D conference, that has arrived now, the 26th edition, you can find all details on this year edition. For instance, in the program menu, you have the complete program with all the various sessions listed. You have time schedule, details about the events, speaker information, and so on. In the same menu, you can also find an at-a-glance version of the program that you can check for having a more general view of the schedule. Taking a look at this program, you can see that this year we have no parallel session. In this way, we eliminated the dilemma of choice between 2 events we like, but that have been planned simultaneously. So you have no excuses to miss a session. To the website, you can also follow the live events, because we integrated a viewer that will stream events live at the specific time in a section specifically created for that, the so-called live section. The same live viewer has been integrated also in the website homepage. So, web3d.cgraph.org is all what you need to follow the conference, or at least it is all what you need for following the conference in a, let's say, passive way. If you really want to participate to the conference, meeting the other participants, sharing your impression with them in a chat room, or actively participating in a Q&A session, we strongly suggest you to follow the conference through the UVA app. UVA is a platform, is the platform we choose to create a place where you can attend live the conference as a community. Access Wova is really simple. There is a direct link in the Web3D website, again, in the home page and in the live section. If you already registered to the conference, clicking on these links, you will directly access Wova. Otherwise, you will be asked to register to the conference before to enter. This registration is free, it takes just 2 minutes, so do not hesitate. If you haven't done so yet, please register. Wova is a visual space where you can find the same information that are in the websites, program, agenda, etc. But also a lot of tools for growing as a community. A message section where to find the latest announcements, a direct channel to communicate with the organizer, a social space for meeting the other attendees, special games for promoting participation, and so on. To watch live events in Wova, you have to access the agenda, then click on sessions, and then select the day and the event you are interested in. Here, you can find a viewer with the events streaming, and just next to the viewer, a place where to chat about what you are seeing, and also sections to ask questions to the speaker. It's important to say that Wova is the only official place where chatting and interacting with speakers. So if you have doubts or curiosity about the content of a paper, or if there is a detail of the presentation that is not clear to you and you want to discuss it directly with the author, then you have to use Wova. Also, it is important to say that the chats and the Q&A session will be accessible even after the end of a specific event. In this way, even though you were not able to follow the event live, you can still follow the chat thread and asynchronously participate to the discussion. The speakers will be encouraged to ask questions for participants for the duration of the conference, even after the session are finished. Wova can be accessed through the browser as a web app, but also as on a mobile device as a standard app. You can download the Wova app on your mobile phone, and in this way you can bring the conference in your pocket with you. We did a good job to make this virtual space as welcoming as possible for you, trying also to meet this year's conference theme, that is a shared 3D workspace. I hope you can appreciate this workspace and also exploit it at the best of its possibilities. Finally, before closing, I would like to spend a couple of minutes talking of the social event. That is another little present we prepared for you. You will know this year the conference should have taken place in Pisa, in Italy. But that due to the emergency situation, this was simply not possible. Well, with our social event, we still want to take you to Italy, to Pisa, and in particular, to the wonderful Piazza dei Miracoli. So the social event will be a Web3D virtual tour accessible through the browser. Then exploiting several panoramic images and a professional guide, it will give you the possibility to visual touch the famous Limit Tower. It will not be a pre-recorded video, but an interactive and live event, which you can access with a link that you can find looking for the event detail. Since it's a live event, we have planned 2 different sessions for the social event, just to cover all the time zones. Through this web application, basically, we will provide you 2 different modes of interaction. You will have the chance to follow what the guide show you, or to wander with your look free around the square while the guide is talking, just like sometimes it happens in a real guided tour. I really hope you like it, as I hope you can appreciate all the rest of the conference. On the behalf of the organizing committee, I greet you and I wish you a great conference. See you the next days. Enjoy Web3D 2021.
Okay, and so far for the logistics, and I told you I was going to forget something in my initial presentation. So what I forgot to mention was the industrial use case session, which is Wednesday, November 10, and contains presentation of 3 different companies that will showcase the technical solution using Web3D technology. So be sure to be there because they are really interesting presentation. So again, I try to redeem my forgiveness. And the last thing in the calendar for today is the presentation by Neil Trivette from NVIDIA and CEO of the Chronos group that will speak about the Chronos group involvement in the Web3D conference. So I give the podium. Neil, thank you for being here.
Hey, thank you for the opportunity to present. You guys seeing my screen okay?
Yes, we do.
Yep, great. So, hey everyone, I'm Neil Trevett. I'm VP of Developer Ecosystems at NVIDIA, and I'm president of the Chronos Group. And Chronos is honored to be a sponsor again here at this year's Web3D conference. So we're happy to have the chance to talk to everyone. I'm going to spend just a few minutes on the latest updates on Chronos. We've tried to choose the interesting parts, so I hope you do find it relevant to your work. So if you haven't met us before, Chronos is an international non-profit standards consortium. It's open to all who want to join. All our standards are royalty-free for the industry to use. Our focus is on enabling applications to access the power of 3D graphics hardware, virtual and augmented reality hardware, and parallel computation. We have about 180 members from around the world, and we are all strong believers in the power of open standards to grow market opportunities for everyone. I've called my talk Standards for the Metaverse. I'm sure people may have noticed the metaverse is the current hot industry topic. And as many believe it will be the spatial evolution of the web, I think it is a significant opportunity for the Web3D community here, particularly as open standards will be critical for building the metaverse. Interoperability standards to enable products and subsystems from different vendors to easily communicate have always been the foundation on which technologies are made available to society at pervasive scale. Couple of examples. I mean, the ubiquitous PC is built from a web of literally hundreds of hardware and software standards, and plugging your PC into the wall outlet takes another whole interoperability ecosystem that has become so ubiquitous that we just take it for granted. And if we're successful as a community, technologies for the 3D web, we hope will also become so ubiquitous that eventually people take them for granted too. But bringing together so many diverse technologies at a global scale is going to take an unprecedented level of interoperability between different platforms and products. And that means we need a strong foundation of cooperative standards for many international standards organizations, including the Chronos Group, the W3C, and of course the Web3D consortium. So I'm going to talk about Chronos here. Chronos has multiple standards that are being widely adopted and hopefully help solve the three essential challenges faced by any 3D spatial application. Chronos's 3D graphics APIs such as Vulkan and Webgl provide portable GPU-accelerated 3D rendering for native platforms and the web. The newer OpenXR API provides portable access to XR platforms, enabling applications to use a wide diversity of XR hardware, devices and runtimes without reporting. And the GLTF runtime optimized 3D asset transmission format enables compelling models and scenes to be efficiently downloaded and displayed. So I'm going to spend just a minute or two on each of these initiatives. Firstly, the big news for WebGL, if you haven't seen it already, is that WebGL 2.0, which was first released back in 2017, is finally universally available. In September 2021, Apple shipped conformant WebGL 2.0 in Safari for both macOS and iOS, bringing desktop class graphics. WebGL 1 was kind of mobile class graphics. WebGL 2 is desktop class graphics. It's a big jump in functionality. And now it's available in over 80% of the world's browsers. So if you haven't been taking advantage of WebGL 2, now is the time. And the WebGL working group at Chronos continues to focus on increased WebGL performance and quality. And there's a lot of ongoing work on expanding the conformance testing suite, for example. And other major developments include making at least one of the two ETC2 or S3TC texture formats available now on all systems, including Apple. Work to access draw buffers index functionality is going to enable advanced order independent transparency techniques. And perhaps the most significant from a performance point of view, the new multi-draw extension can provide significant performance upgrades through enabling geometry batching. And the graph there is an illustration of one company's experiments with that new extension. So for augmented and virtual reality, OpenXR defines a common API that all XR runtimes can expose to application and engine developers, enabling for the first time XR software to be written once and to run on any OpenXR conformant hardware. So OpenXR enables device vendors to continue to innovate in the design and implementation of their hardware and their runtimes. But the industry has now agreed how to consistently expose the capabilities of those XR devices to software developers to avoid industry fragmentation. And the hot off the press news is that OpenXR is rapidly gaining widespread adoption. Conformant implementations now include all the Windows mixed reality headsets and HoloLens 2 from Microsoft, the Rift S, Quest and Quest 2 from Oculus, the Vive Cosmos from HTC, the entire range of Vario high-resolution VR headsets, and more. Valve have publicly stated that all new Steam VR functionality will be exposed in OpenXR rather than the older proprietary OpenVR API. And Facebook has recommended, I guess I should call it Meta now. Meta has recommended that all game engines and applications use OpenXR rather than its proprietary SDK. Both Unreal and Unity engines now have OpenXR support, and the WebXR engine in Chromium, used to bring XR capabilities to the Chrome and Edge browsers, now uses OpenXR as its default backend. And the cooperation between Chronos and the World Wide Web Consortium to bring 3D and XR to the web is a great example of multiple standardization organizations cooperating to advance the industry. The WebXR standard is being developed by the W3C. And Chronos is working closely with the WebXR working group at the W3C so that WebXR can effectively use OpenXR as a native portability API, saving WebXR from having to be ported to dozens of proprietary runtimes. So here Chronos is fulfilling its role in the industry by providing native access to XR hardware, together with 3D rendering for both native and web applications through Vulkan and WebGL. And looking beyond the WebGL 2.0, the new generation WebGPU 3D standard from the W3C will leverage Chronos' native GPU APIs, including Vulkan. Chronos' Gltf 3D asset format continues to gain strong industry adoption in both web and native applications and engines. It grew from the realization that all the major media types, including images, audio, and video, had formats designed for efficient and compact distribution except 3D. And those transmission formats have created significant market opportunities that 3D was missing out on. And so Chronos designed the Gltf 3D asset format to be compact, easy to process, so it could become pervasively adopted. Chronos calls it the JPEG of 3D, as it is the last mile JPEG equivalent that lets you easily transport and deploy and use your 3D assets wherever you need, including in this PowerPoint presentation. Gltf is flexible. It can describe any 3D model from single objects to full scenes with animation. It's a pure asset format that can be used in any runtime or application. Gltf 1.0 was designed to be used directly in WebGL, and so use GLSL shaders to define materials. Gltf 2, the big advance, was significantly broadening the adoption of Gltf by defining physically based rendering, or PBR, materials that are both visually compelling and can be efficiently processed by any 3D graphics API on any system. So support for GLTF is now widespread throughout the industry as companies realize the efficiency and cost savings of having tools and apps and engines that can all communicate assets easily to each other. The companies shown here have all either implemented GLTF support, both in tools that generate GLTF assets and engines and applications that ingest those GLTF models. GLTF is extensible, just like any Chronos standard, enabling it to evolve to meet market demands, such as leveraging Google's Draco geometry compression technology for smaller file sizes. And in December 2020, Chronos released a set of GLTF Pbr material extensions, including clear coat, transmission, and sheen for more visually compelling assets, and a second wave of Pbr extensions for refraction and attenuation shipping in July 2021, and there's more to come. The GLTF Pbr roadmap is interesting. We've collected the industry experts who are carefully raising the accepted minimum bar of Pbr materials that can be rendered universally, including on mobile devices and in the web. And another major development this year, Chronos launched a new version of the KTX GPU texture container format in April. KTX 2.0 adds support for basis universal super compressed GPU textures. This is developed by a company called Binomial, but it's been contributed to GLTF. This compression technology produces compact textures that can be efficiently transcoded directly into pretty much any GPU compressed texture format at runtime. This enables universal GLTF assets with a single texture with significantly reduced download size and reduced GPU memory usage. There's already strong adoption of GLTF with KTX2 in both 3D commerce viewers and apps for streaming large geospatial datasets. But we think this technology will significantly benefit all 3D developers, so please do check it out if you haven't already. In fact, 3D commerce, which is the use of 3D in online e-commerce and is Chronos's newest working group, announced in SIGGRAPH 2019, is a hotbed of activity around GLTF. Studies have shown for many years that 3D is an effective technology for driving customer engagement and increased online sales. So why isn't 3D commerce more widely used? The vision that people have in the industry is to enable CAD tools being used to design a product to also produce standardized 3D commerce assets alongside the physical product. So everyone downstream, including the marketing department, moving to virtual photo shoots can seamlessly use a compelling and deliver a compelling end user experience. But we've come to realize, though, that the barrier to deploying 3D commerce at industrial scale is just a process friction between hundreds of companies trying to cooperate over the design, manufacture, and presentation of millions of 3D products across multiple platforms. And that's where standards can help. And so we have the 3D Commerce Working Group making significant progress on solving these process problems. There's a clear and present commercial opportunity. And the working group is made up of a unique mix of technology and commercial companies. We have the asset creation tool vendors, the e-commerce companies using those tools, and the viewer companies ingesting and displaying the created assets to the end user, all in the same working group. This means we have a very tight loop between the use cases running into problems, insights into the requirements needed to fix those problems, and the expertise to create and deploy real-world solutions. So 3D Commerce has been pursuing 3 tracks of deliverables. The first was to develop a series of GLTF extensions in addition to the Pbr materials, including material variants to efficiently encapsulate a product with multiple versions with different materials while avoiding having to retransmit the asset geometry. and a metadata extension leveraging the ISO XMP metadata platform. The second track resulted in asset creation guidelines to guide designers and artists on how to create 3D assets that can be reliably and easily deployed to millions of end users, including how to use the new KTX2 super compressed textures. The group is now working on an open source asset checker tool to actively guide the creation and assess the reliability of 3D assets for e-commerce. And last but not least, the group has developed a viewer certification program that tests whether 3D viewers from multiple companies are able to accurately display 3D asset files, which will drive consistent end user experiences across the web, social media, ad platforms, and in augmented reality. And once this program has addressed rendered pixel accuracy, the next steps are to drive ecosystem-wide consistency on tone mapping and screen calibration for accurate product display. And so finally, Chronos continues to evolve the GLTF roadmap. Multiple vertical markets are building on the foundation of GLTF 2.0, and so we are considering potential market profiles to enable diverse new functionality without API fragmentation. The first possible profiles include continuing to evolve GLTF 3D commerce, including mesh variants. There is also significant interest in new extensions for geospatial, including point clouds, per mesh and texture metadata, LOD streaming, and using OGCs, that's the Open Geospatial Consortium's emerging GeoPose standard for accurate geospatial positioning. And lastly, to come back to the metaverse, perhaps the biggest opportunity will be upgrading GLTF from a 3D asset format to a metaverse asset format, including composable behaviors, attributes for physical simulations, and advanced animations for avatars. And in this community, for the work on avatars, we would really welcome collaboration with WEB3D, HANIM, and IEEE P3141 3D body processing. We want to use and leverage that work, not duplicate or compete with it. Hopefully, that can be another good example of standard organizations working effectively together. So that's it. That was a lightning update on the latest happenings at Chronos. As always, if you would like to be involved, any company or university is welcome to join. And with that, I wish everyone here an enjoyable and productive Web3D conference. Thank you.
It was a lightning update, but it was a very complete one and a very interesting one. Yes, these things about the metaverse is coming up and up. So even in the last meeting we had of the committee, someone said, well, mostly joking probably, oh, next year we should have part of the conference happen in the metaverse. And, you know, I was kind of skeptical, but it seems that things are moving quite fast at the moment. So what do you think? Not just Neil, also the other panelists and the people that spoke today. You think it would be feasible to have next year half of the conference physical, hopefully, and half of the conference really in a virtual way, in a virtual environment? That may be an interesting challenge.
Marco, we've discussed this within our group here. I mean, we are Web3D. We should be doing this now. But I
now,
think,
like tomorrow, no.
No, we should have been doing this for this conference, I meant. But I think it's a good goal for us to target for next year. Maybe we'll have tools and technologies available to do that. And I think next year also could be a hybrid conference where you would have in-person as well as virtual. And when you have a hybrid situation, I think a metaverse environment would be very good and perfect. So yes, Neil, we would like to work with you. We would like to work with your team, Marco, and let's make this happen next year.
I think it would be great. I mean, I've been to several shows that have used like what I call today's avatar technology, and you think it's going to be a good idea, but then you actually go into the virtual environments, and of course all of the avatars are just standing there like wooden stick figures just staring at each other. So you don't actually get more social interaction than you get through Zoom chat. But I think we are on, as several folks have already said this morning, we're on the verge of much better face and hand tracking. I think once we can break through that barrier, then the value of social interaction will be sufficiently higher through going into virtual that it will become more widely used. And we should, I totally agree with Anita, we should be on the cutting edge of that, right?
I think having a video stream in there, you know, you're in a virtual environment, but have your video stream into that virtual world would be great.
Yes, that's
so not an avatar, just a video stream of yourself into the, like how we are video streaming into the Zoom meeting room. It would, instead of the Zoom meeting room, it would be a virtual meeting room, and you would have your video stream in there.
Yep, that is probably a shorter term way of doing it. Yes. So, if I may, I mean, William asked a question. Okay, would you like me to answer that on the yes. So how does the industry consider file formats for the evolution of objects like an auto that accumulates things, scratches, dullness, etc.? So I think in general, I'm personally a believer in building the metaverse from the ground up rather than people trying to dictate how it's going to happen from the top down. And just having interoperable asset format seems like a simple, sure it's not, but it's a good starting point to say, okay, let's have an asset format that we can pass around to the different parts of the metaverse. The evolution of manufactured items, or as cars degrade, I think maybe that is pointing to another really interesting use case, which is real-time capture. The iPhones with LiDAR leading the way, but that's becoming increasingly common. So it's not just going to be produced assets, it's going to be end user authored assets, including real world captures, I think will be an essential part of the overall metaverse.
No, please. Yeah.
Yes, comment, please.
Yes, please.
Sure, go ahead, Don.
Yes, hi, Neil. Hope you can hear me. I just want to say thank you for so much work. A lot of this, not everybody has the opportunity to pay attention for years on end, but you've been central to so much of this progress, so much of this breadth. So not just your sponsorship of the conference, but how things are working together. So I just wanted to point that out to everybody and thank you publicly.
Thank you, Don, and you too. I've given up counting how many years we've been doing this together. It's getting too depressing.
Well, the human mind has a wonderful ability to forget pain, so I'm grateful for that. Let me give 2 check marks and a maybe. We should look at something. It's in the chat. First, 2 points in your presentation that really resonated were first. Actually, I'm sorry, 3 point. GLTF, of course. We're really rocking. We're very glad about the collaboration. We're getting great strides with that. And without breaking anything, the wisdom of the GLTF folks means all our old rendering model stuff can coexist in the same models and mashups, whatever. Okay, the 2 check marks for upcoming work, textures. KTX, gee, we have textures too. Gee, maybe we could use KTX textures. That seems like a natural for next year. A little farther ahead, but not too far, is the XMP metadata. We landed on the same place through the CAD and the STEP communities. So I just offer those as likely work in the coming year. But let me add one more thing, please, and that's the health and safety issues. You're aware that there's that started, and the ICE committee. I think that's not well recognized yet, and that there are potential hazards to individuals, to others. These don't have to be showstoppers, but they don't have to be a shock or a surprising disaster if some things start to happen. So I just want to reach out and say, boy, I hope we could all together carefully look at that in the coming year so that nobody gets whipsawed by unintended consequences. Over.
Yeah, totally agree. Health and safety, and also privacy and security. These are totally central things.
Thank you.
We didn't build it in at the foundation of the internet. Let's not make the same mistake again.
Yeah, that's right.
I just saw Carol's comment on the chat. Totally, Carol. Thank you for saying that. So let's reach out and make that happen. We are really interested to leverage the work that you've done there with the IEEE.
Yeah, we have a meeting next week. Would you like me to invite you?
Yes, please.
All right, I'll add you to the invite list.
We have also another question in the chat, I believe, from William.
Yeah, so William's question is, how do we bridge this gap between the 3D graphics mechanics and the psychology of expressions and postures and positions? And I think that this is a great example of where no one group can do everything. No, Chronos, for example, we are not the experts on psychology and human body processing. We know how to do blend shapes, and carry that animation information in a 3D file format that we've heard are what people are looking for to animate facial expressions, but we would not be the people to say, okay, these are the facial expressions that need to be animated. So we need to find a web of cooperative standards organizations that have the right pieces and bring them together into a coherent whole. So yeah, Chronos, we're very careful not to walk outside our area of expertise. We tried that once, it didn't go very well. we tried to stay close to our core mission, which is hardware acceleration APIs and formats.
Also because that is also cultural, it will change like a language, basically.
Mm-hmm. Right, yes, absolutely. And Carol just asked a question, is Chronos working with Gltf 3D, Browseware, Lecturer, or equivalent CAD software? We've had, it's funny you should say that, we've just had them reach out to us. So I would say it's very early days. We've been in several joint panels, but nothing substantive has happened yet. I think this is the good time to bring those parties together with you, Carol.
What about Rhino 7?
Same thing. We've had disciplinary contact. Nothing substantive has happened yet, but there seems to be, in general, interest. There are some proprietary systems out there that may be latecomers, but in general, there seems to be growing realization that we all need to work together on this.
This would be pretty huge for getting the file formats. I mean, IEEE we have tried for years, so if you can get them to finally talk, that'd be awesome, and we'd love to be a part of that. And there's also 3DRC and all the other people, especially with your file formats. There's a group of 3DRC that's working through that as well. If you want the contact, that might be helpful.
Yeah. You know, it's maybe I'm just thinking as you were talking, I mean, maybe what we should do with your help, Carol, maybe we should arrange a little mini summit and have anyone who's interested in, you know, apparel and avatar fit and body processing to come together to swap notes. That there are multiple threads ongoing in the industry. It sounds like, you know, a good time for some communication between the groups.
Yeah, we tried, but you know, when you approach the brands, they immediately clam up because they're so afraid that you're going to steal an idea.
Right.
So I think going through kind of a third party, maybe you know, Avalon or PI Apparel or somebody, I think we can get there. So I may have just been a year too early. They're still all really touchy about COVID and the impact of their supply chain.
Yeah.
So yes, so why don't you and I meet and offline? Clearly, sorry guys, but I think this would be good.
Yeah, absolutely.
Okay, thanks.
Okay, thank you to all the participants. Unless there are other questions from the audience, I believe we have reached the end of the first day, and nothing crashed, which is surprisingly good. And we hope tomorrow to be even better than today with the timings and with the technical things. And we will start tomorrow morning, well, our morning, with the HANIM music video competition. And then we will move to the poster presentation. And then in the afternoon, we will have 2 tutorials and a workshop. So be sure to check in with the agenda to see if there's something that you want to see. And for any problem, just reach out through the WEB app or through our email. We can answer you and try to solve any possible issue. As we said, the recording of today will be put online after we have just finished this streaming, and we connect the video in the different sessions. So thanks again to all the speakers, and thank again to everyone that helped in setting up the conference. Thank you for being here at this event. We're happy to see people attending both here and on YouTube. It will be a nice week, and we will get together until the end of the week with a lot of interesting stuff.
Thank you.
Okay, so I will stop the recording and then I will stop the broadcasting on YouTube.
Bye-bye.